In today's video, we're going to look at how to solve quadratic equations by completing the square. So let's just recap what we did in yesterday's video. The very first thing we looked at yesterday was using the square root property to solve a quadratic equation. And we were able to do that if we had a perfect square that equaled a number. And in this case, for this example, we do. We have a perfect square and it equals a number, so we can take the square root of both sides to get rid of the square here, right? And we end up with a positive answer and a negative answer. And then we set two equations up and solve for x. But what if we start with an equation that looks like this? We have a perfect square, right? We have a perfect square here. But if we move this second term and this third term to the other side, we have a variable x on the other side. And we can't define x in terms of itself. So we can't just move 10x and 3 to the other side. So it would be really nice if we could turn this into a perfect square. But I know that if I find what multiplies to 3 that adds to 10, like if I could factor this, I could use the zero product property to solve this equation. I know that the only two numbers that multiply to 3 is 3 and 1, but 3 and 1 do not add to 10. So this equation can't even be factored. But maybe, just maybe, I could take this equation and I could turn it into a perfect square. Okay, if I move that 3 to the other side, maybe I could come up with some constant here that I could add to the left side, and I have to add it to both sides or else my equation is no longer balanced. Maybe I could find a constant that I could add that would make this a perfect square, something that factors into this. Okay, so then I could use the square root property. Well, let's see if we can. I know my perfect squares look like x plus a squared and x minus a squared. Those are perfect squares. So let's see if we multiply these out, what do we get? And can we take any of the terms to figure out the number to add, the constant to add to make it a perfect square? So let's distribute this x and we get x squared plus ax. When we distribute the a, we get ax plus a squared. And now when we combine like terms, we end up with x squared plus 2ax plus a squared. Well, that's really convenient because if I have the first term and the second term, the squared term, and the term of power of 1, this constant in front, the coefficient in front of the x, has an a in it, right? It has an a in it. How do I get the a out? Well, geez, I could just take the 2x or the 2a, I could multiply it by a half to get a, and then I could square that number to get a squared. Can I do that if it's x minus a? Well, let's see. X minus a times x minus a equals x squared minus, not a plus, minus ax minus ax plus a squared. So when I combine these two terms, I get x squared minus 2ax plus a squared. Check this out. If I have a first term and a second term, in order to figure out the constant that makes it a perfect square, I can take the number in front of my power 1, my x variable, okay, and I can take that. If I multiply it by a half, I get negative a, and then if I square it, I get a squared, which is exactly the constant I need. Okay, so that tells me that up here in this little example here, if I take the value in front of my x term, which is 10, a positive 10, if I multiply it by a half and then square that, I get my a squared value that'll make it a perfect square. So if I add 25 to both sides, I can factor this quadratic equation on this side into x plus 5, and when I add the 25 to the other side, I get 22. And I want you to notice that this factor here is always going to show up in your factor when you factor it into a perfect square. So we're going to go through some examples. The first, and I know this is a little confusing when you first start off, but be patient with yourself, and we're going to go through these examples by starting off with just finding the constant that you need to make it a perfect square. All right, so I need this value in front of my x. So I'm just going to call that value b, and the reason I'm going to call it b is because when we write out just a generic quadratic expression, we usually write it as ax squared plus bx plus c, and we name the number that's in front of the x value, we name it b. So I am going to start off by saying we need to find the b value. We need to multiply it by a half, right? Because this b value is going to equal 2 times a. And then we need to square it to find the number that we're going to add to make this a perfect square. So when I do that, my b value here, the number in front of my x term, I'm circling it, is a positive 4. So I get 4 times 1/2. And then I need to square it. 4 times a half. Okay, remember we can reduce. 2 goes into 4 2 times. So I get 2 over 1, which is 2. And then when I square it, I get a 4. Okay, so I'm going to write the 4 on the line. That is the value that I need to add to x squared plus 4x to make it a perfect square. And then I'm going to factor it. Okay, I'm going to factor it and find out what perfect square I just created. So what are the factors of 4 that add to 4? Well, I know it's 2 and 2. 2 and 2 work. All right, so I'm going to place a positive 2 here because my two factors, x plus 2, they're the same factors, so I get x plus 2 squared. All right, let's try another one. All right, so I need to find my b. I need to multiply it by a half and then square that value. So in this case, b here is a -6. The value in front of the x term is negative, so I get -6 times 1/2, and then I'm going to square that. So I know that 2 goes into -6 -3 times, so I get a -3 over 1, or just -3, and -3 times -3 is a positive 9. So I know that I am going to add a positive 9. So what are the factors of positive 9 that add to -6? Well, I would say -3 times -3, and that works out. So when I factor this, I get x minus 3 times x minus 3, or x minus 3 squared. All right, let's try the next one. Oh, I forgot my x value here. That's important. Let's try the next one. I need to find my b value, multiply it by a half and square it. In this case, I have a positive 1/5 as my b value. 1/5 times 1/2, and then I'm going to square it. So I know I multiply my fractions across, so I get 1 over 10 that I have to square. And when I square a fraction, again, I'm multiplying numerator and denominator. Right, I'm multiplying across, so I have to add 1 over 100 to this in order to turn this into a perfect square. So how do I factor something like that? I need factors of 1/100th that add to 1/5. Well, I know that I multiplied 1/10 and 1/10 to get 1/100th. Do they add to 1/5? Well, I would say yes, because 1/10 plus 1/10 is 2/10, and when I reduce that, I get 1/5. So I would say 1/10 is the number I'm going to use for my factors. 1/10, x plus 1/10, x plus 1/10. So I get x plus 1/10 squared. All right, so let's go ahead and do our next example here. X squared minus 2/7 x. What do I have to add to turn that into a perfect square? So I know I have to find my b value. I need to multiply it by 1/2 and square it. I'm going to circle my b value, the number in front of x. So I get negative 2/7 times 1/2, and then I have to square it. Well, I know that 2 and negative 2 reduce to negative 1. So when I multiply across, I get negative 1/7. And when I square negative 1/7, that's multiplying it twice, so I get a 1/49. So I need to add 1/49th in order to turn this into a perfect square. So how do I factor that? Again, I have 140, what are the factors of 1/49 that add to a negative 2/7? Well, I know I multiplied 1/7 and 1/7 to get, or negative 1/7 and negative 1/7 to get 1/49. When I add them, do I get 2/7, negative 2/7? I do. So my factors would be x minus 1/7 times x minus 1/7, or x minus 1/7 squared. All right, this is the last example we're going to do on this video, and then I'm going to start another one to do the last 3. Okay, so how do I find the number to add to make this a perfect square? All right, so I know I have to find my b value. I'm going to multiply it by 1/2 and then square it. So what is my b value? It's a positive 2/9. So I'm going to take that 2/9, I'm going to multiply it by 1/2 and square it. I know when I reduce the 2's, I get a 1. And when I multiply across, I get a 1/9. When I square that, I get 1/9 times 1/9 equals 1/81. So how do I factor that? Again, I'm looking for factors of 1/81 that add to a positive 2/9. Well, I know I multiplied 1/9 and 1/9 to get 1/81. If I add them, do I get 2/9? And I do, so my factors are going to be x plus 1/9 times x plus 1/9, or x plus 1/9 squared. So let's go back, and I want to point something out really quick before I do the next video. We don't actually have to do this step, because the number before you square it will be this number here. So that's a positive 1/9. So in my factor, I see a positive 1/9. Let's see if that works in all of our cases. All right, so the number before you square should be in your factor. I see a negative 1/7, and I get negative 1/7 in my factor. I see a positive 1/10 here, and I see it in my factor. I see a negative 3 here, and I see it when I factor it. Here I see a positive 2, and I see it in my factor. So I don't really need to go through this step, because it's always the number before I square that shows up in my factor, and that'll make my life a lot easier. So now I want you to go ahead and quit this video, and I want you to move forward to the next video to see how we're going to solve equations, quadratic equations, by using this method.